For 200 years, not a single sapling took root here. Just ancient Scots pines, some carrying a 9,000-year genetic lineage, slowly dying across moorland grazed bare by nearly 1 million deer. Then someone built a fence through the dead ground. No planting, no seeding, no soil treatment. Within years, one side erupted into what looks like an impossible forest. The other side stayed exactly as barren as before. To understand what that fence actually unlocked, you first have to see what Scotland lost. 12,000 years ago, as the last glaciers melted from the Scottish Highlands, a vast woodland advanced northward. Scots pine, birch, oak and rowan formed a living tapestry that stretched from the Atlantic to the eastern valleys, covering nearly 1.5 million hectares. This was the Caledonian forest, an unbroken expanse where light filtered through ancient canopies, and the ground was thick with moss, heather, and wildflowers. Wolves trod silent trails beneath the trees, lynx and brown bear hunted along the riverbanks, and herds of red deer, wild cattle, and even beavers shaped the land's rhythms. The forest was not a patchwork, but a single, breathing organism, its roots and branches interwoven across the highlands for millennia. In the pollen records buried deep in peat bogs, scientists still find traces of this abundance. Layer after layer, they reveal centuries when the forest barely changed. For 6,000 years, the Caledonian Pinewoods endured, their genetic lineages stretching unbroken from the end of the Ice Age to the present day. Some of the Scots pines that stand now, gnarled and wind-bent on lonely moors, carry the same DNA as those first pioneers. Each tree is a living link to a world where the forest was the rule, not the exception. The richness of this ancient woodland defies modern imagination. A single hectare could shelter more than 1,000 species of fungi, mosses, and lichens. Birds nested in every layer, capercaillie booming in the dawn, crossbills cracking pine cones, redstarts flitting through the undergrowth. The forest floor pulsed with insects, from wood ants building towering mounds to rare butterflies feeding on bilberry and blaeberry. Streams ran clear and cold, their banks shaded by willow and alder, home to otters and the now-vanished beaver. Every part of this ecosystem depended on the others, each species woven into the cycles of growth, decay, and renewal. For generations, the Caledonian forest seemed endless. Its trees grew old and died where they fell, feeding the next wave of saplings. Fire and flood opened new glades, but the forest always returned. Even as the first humans arrived, lighting small campfires and hunting along the margins, the woodland's reach remained largely unbroken. The stakes were immense. This was not just a collection of trees, but a cradle for Scotland's biodiversity, a living memory of the land's original abundance. To witness what survives today, set against this backdrop, is to feel both awe and a deep sense of loss. In the Scottish Highlands, the absence of wolves since the late 1680s and the earlier loss of lynx and bear left deer populations unchecked. Today, nearly 1 million wild deer roam a country with just over 5 million people. Each year, more than 100,000 are culled, but the herds persist, buoyed by mild winters, the lack of natural predators, and centuries of estate management that favor open moorland. The scale is staggering. In many areas, deer densities far surpass the 4 deer per hectare threshold needed for native pine and birch to regenerate. Some estates report 10 or more deer per hectare, a level that all but guarantees any seedling is grazed down before it can reach safety. Over time, this relentless browsing has trapped the landscape in a state of arrested development. Ancient Scots pines, some rooted for 9,000 years, stand alone in seas of heather and grass, their seedlings unable to survive the constant pressure. The forest is not gone because the land is poor or the climate unforgiving, but because a single ecological process has been broken. Efforts to reduce deer numbers have become a national concern. Government agencies set ambitious targets, and professional stalkers work year-round, yet the overall effect is limited. Deer move freely across estate boundaries, finding shelter in remote glens and replenishing culled populations from neighboring lands. Even with annual culls exceeding 100,000, recruitment outpaces removal, and local reductions are quickly erased. The challenge is not just the sheer number of deer, but the fragmented ownership of the land. Some estates maintain high deer densities for sporting revenue, while others seek woodland recovery. The result is a patchwork of priorities that makes coordinated action nearly impossible. The landscape remains in ecological gridlock, with the recovery of native forest blocked by a single unresolved question: how to bring deer numbers low enough for trees to return on their own. The impact extends beyond trees. High deer populations strip ground flora, including bilberry, cowberry, rare orchids and mosses, leaving little habitat for insects and birds. Soils are compacted by hooves, deprived of the leaf litter and shade that once built up deep carbon-rich layers. Mycorrhizal fungi, vital for nutrient cycling, struggle to survive in thin, eroded soils. Without young trees, there is no shelter for capercaillie, no nesting for redstarts, and no food for crossbills. The entire ecological community of the Caledonian forest is held in suspension, its future dependent on a single unyielding pressure from above. Centuries of human intervention, clearing, burning, hunting, and predator removal have left a legacy that planting alone cannot fix. By the 1990s, frustration led scientists to try a new approach: fencing small plots to exclude deer. The results would soon upend assumptions about what the highlands could become if browsing ever stopped. Across the highlands, the last vestiges of the Caledonian forest survive as scattered outposts, 84 fragments, each clinging to its own patch of wind-battered ground. These remnants are not forests in the old sense, but islands of memory surrounded by a sea of heather and grass. The trees that remain are mostly old, some impossibly so. In Glen Loyne, a single Scots pine stands sentinel, its heartwood traced by dendrochronologists to the year 1459. 565 years have passed since it first pushed a root into peat. It has watched the world change around it, outliving kings, clearances, and the slow retreat of its own kind. Within these fragments, the genetic legacy of the Caledonian pine endures. DNA studies confirm that these pines carry lineages unbroken for 9,000 years, a living bridge to the post-glacial forests that once covered northern Europe. Yet, their numbers dwindle each decade. Conservation status reports warn that fewer than 2% of the original Pinewood remains, and even these are shrinking. The 2023 Trees for Life survey catalogued the fragments Mar Lodge, Glen Affric, Rothimercus, Abernethy, each a name on a dwindling list. Some fragments are less than a hectare, their oldest trees hollowed by wind and time, their youngest nipped off before they can grow. The stakes are not just botanical. These fragments shelter unique communities, rare fungi that fruit only on ancient bark, lichen mosaics found nowhere else in Britain, and birds like the capercaillie whose fate is tied to the pine. Where the canopy thins, so do the numbers of crossbills, redstarts, and black grouse. Insects that depend on old pine resin, or on the cool, mossy shade, disappear as the forest ages in place. The loss is quiet, but it is relentless. Among naturalists, there is a sense of urgency bordering on grief. Each year, more of these old trees die, with no saplings rising to take their place. The fragments grow smaller, the genetic pool tighter. Without intervention, the living archive of Scotland's wildwood could be lost within a generation. The question is not whether the forest can return, but whether it will be allowed to. The answer, as the next experiment would show, lay not in planting or soil amendment, but in removing a single barrier. At Mar Lodge, a simple fence drew a line across centuries of ecological standoff. On one side, the moorland stretched empty and silent, the ground stripped bare by deer that wandered unchecked. On the other, something extraordinary began to unfold. Scientists set up long-term monitoring plots, marking every seedling, every patch of moss, every trace of returning life. The initial surveys were bleak. Before the fence, not a single pine sapling had survived beyond a few inches. The old trees stood isolated, their offspring grazed down year after year. But inside the exclosure, without a single tree planted or a handful of soil amended, the transformation was immediate. Within the first growing season, pine and birch seedlings broke through the heather, their numbers rising from 0 to thousands per hectare. By the 4th year, saplings reached heights unseen in generations, growing 3 to 4 times faster than their counterparts outside. The ground, once compacted and lifeless, softened under a new layer of leaf litter. Heather, blaeberry, and cowberry returned, followed by rare orchids and carpets of moss that had not been recorded in decades. It was not just the plants. Black grouse, absent for years, began to display again inside the fence. Crossbills and redstarts reappeared, feeding and nesting where there had been only silence. The monitoring team, led by ecologists from Trees for Life, documented the shift in meticulous detail. Sapling density inside the fence soared to over 4 per square meter, while the outside plots remained barren. No planting, no seeding, just the removal of browsing. The contrast became impossible to ignore. Photos taken at the fence line showed a living forest on one side and a dead zone on the other. The only difference was a barrier that kept deer out. The data told the same story. Before fencing, surveys recorded 0 successful regeneration for over 2 centuries. After fencing, the genetic legacy of the Caledonian pine, 9,000 years in the making, surged back into the light. For the scientists who watched this unfold, the message was undeniable. The highlands were not broken beyond repair. The forest's resilience had been waiting, dormant beneath the heather, for a single pressure to be lifted. The fence did not create a forest. It revealed one, hidden in the seed bank, the soil, and the memory of the land itself. What grew inside was not a miracle of intervention, but a return to what the land had always been capable of, if only given the chance. Beneath the surface of the reborn forest, a hidden world pulses with activity. Mycorrhizal fungi stretch their hyphae through the soil, weaving a silent network that links roots, trades nutrients, and unlocks the mineral reserves that trees alone could never reach. In the Mar-Lodge exclosure, soil cores revealed a surge in fungal diversity within just a few years of fencing. The difference was not only visible above ground, but measurable below. The density of ectomycorrhizal spores doubled, and the network of fungal threads thickened, connecting pine, birch, and willow into a single living system. This underground alliance is not random. Studies across the highlands have found that nearly 3/4 of new pine seedlings, about 71%, establish within 2 meters of a willow. Willows act as mycorrhizal hubs, their roots radiating fungal highways that seedlings tap into for a crucial boost. The effect is so consistent that, in some plots, the presence of willow predicts not just where young pines will appear, but how likely they are to survive the first harsh winters. These relationships are not just academic curiosities, they are the biological engines of recovery, quietly rebuilding the forest from the roots up. But the fence is not a magic wand. The same barrier that keeps deer out also shapes everything inside. Maintenance demands are relentless. Annual inspections, repairs after storms, and in steep terrain, helicopter lifts for replacement posts. The average cost, tallied over recent years, sits at £1,550 per hectare each year. And the fence itself is not without consequences. Capercaillie and black grouse, low flyers in the dawn, have collided with the wires. 12 capercaillie and 7 grouse lost in the first decade before retrofitting with high-visibility sleeves reduced the toll. Dense regrowth can smother rare lichens and bryophytes, while shade-loving grasses sometimes outcompete seedlings, forcing managers to mow or thin, adding to the expense. Inside the fence, life surges forward, but the system is not self-sustaining forever. The exclosure reveals the land's potential, but it also draws a hard line between proof and permanence. Fences are expensive, imperfect, and over time, risk creating islands of recovery in a sea of decline. The lesson is clear, the resilience is real, but the solution cannot stop at the fence. The real challenge is scaling up, learning from these living laboratories, and asking what happens when the pressure is lifted not just on a hectare, but across a landscape. Across the Cairngorms, the fence experiment has already leapt from plot to panorama. In the heart of the national park, coordinated deer management has driven densities below the 4 per square kilometer threshold. No fences, just a shift in pressure. The result is visible not just in a single glen, but across 60,000 hectares, where pine seedlings now appear up to 5 kilometers from the nearest mature tree. Regional surveys over the last decade mapped clusters of young Scots pine and birch in places where, for centuries, nothing grew taller than the heather. The farthest seedling recorded, 5.1 kilometers from its parent, stands as living proof that the forest's reach is limited not by the soil nor by the wind, but by the jaws of deer. Policy analysts tracking these changes see more than just trees returning. They see a landscape shifting toward resilience at scale. The Cairngorms Connect partnership, through annual culls and community-led monitoring, has shown that when browsing falls below the critical threshold, regeneration is not confined to the shadow of old pines. Seed and spore, carried by wind, water, and wildlife, colonize ground once written off as lost. Mycorrhizal fungi, long suppressed by overgrazing, double in density within new seedling clusters, rebuilding the invisible networks that bind the ecosystem together. The stakes reach beyond woodland. Scotland's peatlands, covering a fifth of the country, store more carbon than all the nation's forests combined, about 3.5 billion tons. Yet 80% of these peatlands are degraded, slowly releasing carbon back into the sky. Where native trees return and deer pressure falls, peat soils begin to recover too. Litter from new growth rebuilds the organic layer, slowing erosion and locking away more carbon each year. Models suggest that restoring pinewood across the Cairngorms could sequester nearly 500,000 tons of carbon dioxide annually, a climate dividend that rivals the impact of re-wetting peat. For those shaping policy, the lesson is clear. The fence is a magnifying glass, not a blueprint. The real transformation comes when the conditions inside the exclosure are scaled to the open landscape. When deer are managed at the right level, the forest's ancient memory stirs, not just in protected fragments, but across entire valleys. The question that remains is not whether recovery is possible, but how far we are willing to let it spread. Today, the line between barren silence and wild abundance runs not through the soil, but through the presence or absence of unchecked mouths. No planting, no seeding, no soil tricks, just patience and a barrier against relentless grazing. The Caledonian Pinewoods still carry a legacy of 9,000 years, ready to awaken. The true test now is this: what could return if we simply step aside? Let me know what you think below.